We're going to solve 14. So, Leslie, going to take the lead. Go ahead. 2 to the
fourth.
Whoops, so close.
I'm sorry. To the
third, and then we still have our 3x minus 1, which we're going to put in parentheses. Okay? 32. That must be 2 to the 4th then, yes?
No.
No.
It's the fifth.
2 to the 5th. Okay? 5th, and I'll put an equal sign in between here. And then up here, I got 2x minus 1. Hey, guess what happens when I have the same base? What can I do with my exponents? Make them equal to each other. Okay? So 3 times 3x is 9x minus 3 equals 5 times 2x is 10x minus 5. Move my x's to the right, my numbers to the left. Guess what number do I get? 2. Hey, wow. Let's see. 1, 2, 3 steps. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8's not bad. It's just long. Okay. And then I'll leave the check up to you. Questions? All right. Anybody want to do a graph? No. Nobody wants to do a graph? Yeah, maybe one. This one. Okay. Bree, pick one. Either Bree. That's why I called you Bree. Bree. 17. Okay. All right. So log base 1/5. Now remember, these fractional ones get a little tricky. Okay. You guys are honor students. You ready to make this a little less tricky? Yeah. I won't do this with my core or my intermediate algebra, but 1/5. Okay. Remember, a logarithm is an exponent. So let's just go to Desmos for a second. Now let's just say, I guess we should use this one here. This was 17, right, Bree? Yeah. Okay. So, why did it put it above it? Should put it below it. Okay. So 17. So let's just say y equals log base 5. It's not base 5, it's base 1/5. Bear with me. Oh, I need to get rid of these other ones. What others are active? That one's active. I don't want that. And there's still a white thing in there somewhere. There it is. Yeah, it's a white graph. Okay. So, let's turn this. Is this one still white? Oh, this is the white one. Except I want to be able to see it. So, white is not a good color for a graph. I don't know why they even have that one. Let's go orange. Go Suns. All right. Ready? Y equals log underscore of 0.2x. 0.2, sorry, of x. They look like they're what?
Yep.
Is there another way I can reflect things besides messing with the bases? Look at that. So guess what? I could take this problem right here and rewrite it as such. This literally just dawned on me when we started this problem. I don't know why. I've been doing this, teaching this stuff for years. So I can make this negative log base 5 of x minus 4. Ooh. I don't have to worry about that 1/5, because if you have that 1/5, it's an issue. Okay? So see if you can at least figure out the range. All right. So range will always be for logarithmic functions. If I take a look at my graph, so let's just turn this one on. Okay. Nope. Let's put that one back on. I got positive y's, I got negative y's, I got 0. All real numbers. Okay, so all real numbers, aka from negative infinity to positive infinity. Negative infinity to positive infinity. Okay. Domain, I need to tweak my graph here because right now I just have x. So x minus 4, watch what happens. Shifts it 4 to the right. Hey, that sounds like a transformation. Why don't I put that down here where it says transformations? And if you want to write the transformation, you can do it one of two ways. You can just say moves 4 to the right. Okay, 4 to right. But if you want to get fancy and did what I did up here and rewrite it as a negative logarithm, you could also say something along the lines is it reflects across the x-axis. Okay. All right, so let's put the graph here. And I don't think gray is going to be such a great color either, so let's make it, let's stick with our orange. Playing Atlanta tonight. Did it download? Yeah, download. Okay. So I come back here. I add from my downloads folder graph number 77. Move it over here-ish. I'm just going to make it a little smaller so I can answer the questions. Okay. So left-hand side. 3v. That's my asymptote. But we write asymptotes as equations, so what do I need with the 4? I need 2 more. A bit. 3v. Vertical line. So what's 4? X or Y?
X.
All the x's, right? So it would be a good equation if all the x's were 4. We need an equation, we need an x, we need a 4. What are we missing? Between the x and the 4. Has to be an equation. Come on, Bree, I know you got it. You can say it.
Yeah, right.
Killing me, Smalls. All right, Matthew, help her out. Equal sign. So my asymptote is always in the form for a logarithmic function x equals whatever this number is here, whatever is being subtracted from the x inside the parentheses. Okay. So that's also where my end behavior is on the left-hand side. So as x approaches 4, it's going way up. How far up? All the way to infinity. And as x goes to the right, even though it doesn't look like it, it is going to keep going down and down and down and down and down to negative infinity. Okay. I do have an x-intercept. Let's go back to Desmos. I think it's pretty easy to identify here, but let's just be sure. Yep, that's 5, 0. So we have an x-intercept. Does it have a y-intercept?
No.
Because it's all the way over here. Doesn't even hit 4, let alone anything smaller than it. So 5, 0. No y-intercept. If you want to get fancy, use your equation. It'll be a nice little italicized none or nonner, non-re. And that's it. Oh, domain. Sorry, domain. So notice the end behavior, the asymptote, and the domain all start with 4. No bracket, all the way to infinity. And that's it. Questions? Let's go through our logarithmic properties. We've got the power property. Is that going to apply here? Nope, because there's nothing in front of any of the logs. So it's not the power property. I got the product property. Is that going to apply here?
Yes.
Ahmad, which side is the product property going to apply to, the left or the right? Got a 50-50 shot here, Ahmad, even because I know you weren't paying attention at all. It's okay. 50-50 shot. Left or right? So close. Okay. Product property applies when it's a plus sign. So I'm going to use a product on the left, which leaves what? A quotient on the right, which means multiplication on the left and division on the right. So log base 4 of 2x times 3 equals log base 4. I would make a parentheses here. You don't have to, but I think it's easier. The easiest way, divided by 4. Okay. So I don't need the log base 4 anymore because I have a single one on each side. 6x equals 3. What do I multiply 6 by to get 3? 2. 6 times 2 is 3.
No.
Divide by 6, and that's not 2, but the reciprocal thereof. No, you got to listen to my words. My almost 24-year-old used to do that all the time when I was a kid. When he was a kid, grab my cheeks when he was like 2. Listen to my words. He'd say it real slow, so I understood what he was saying. Smart ass then, he's a smart ass now. Yep, that's recorded. Okay. All right. This one. All right. Oh, we didn't get to some of these. Take a look at the last bunch, unless somebody has a specific question on anything up to and including 24 that we didn't do yesterday. 22. Okay. So, same process as the one we did on 23. So I'm just going to go through the first couple steps. Okay. I don't remember. Take a look. So, log of, oopsies, we're going to use a product rule just like we did in the last problem. X minus 3, close it, equals 1. I solve logarithmic equations with variables attached to the log. So I change it to exponential. You see a theme here? Okay, if it's exponential, most of the time you'll turn it into logarithmic, unless it was like number 14. And if it's logarithmic, you will change it into exponential. It's really not any trickier than that. Okay? The hardest part is making sure you know which logarithmic property to use. So we're using product property. So equals x squared minus 3x. So just like we did on 23, take a look at 23. Can't have the 10 on that side, got to move it. So the good news is 10 to the first is just 10. So I'm going to do 2 steps at 1 and flip everything around. I like the stuff on the left. So x squared minus 3x. Okay. So we factor it. Okay. So I factor it. I get x minus 5. X plus 3. And I got equals 0. I got 2 answers. I got x equals 5. X equals 3, and I must be done because I am so good at solving algebraic equations. No, because I got to check. 5 works. Okay, how do I know if 5 works? This is the 4th time I've done it today. Okay, so here's number 22. You go away. There we go. Okay, come on down. So here's 5. Log 5 plus log 5 minus 3. That works out to be 1. What doesn't work? Negative 3. I don't know why I have a negative 2 here. Nobody told me about that before. So once I put the negative in, I can't take the logarithm of negative numbers. So I go back to my problem, and I cross out the one that is negative. Oh, I know why it is negative 2. What happens when I go too fast? That's a dose. That's a dose. And back here, I love undo. Bye-bye, 3. There we go. All right. You want to write the word extraneous? Okay. Of course, you could link the document to your Desmos if you so desire. Questions? Any others before 22? Okay, so let's say about 10 minutes or so. And I want you to look at the multiple choice types. Okay, so Mrs. Meddy pulled these from ACT prep questions. Those of you that are juniors will be taking